Hey guys, welcome back to the TensorFlow tutorial. So in the previous lecture, we have seen and understood completely what is a TensorFlow pipeline, right? So in this lecture, we will see what is TensorFlow, and we will see some basic concepts like the shape of a TensorFlow, the type, the graph, the sessions, and some operators. Okay, so it's a very interesting lecture. So you all know that TensorFlow's name is directly derived from its core framework, that is Tensor. In TensorFlow, all the computations involve tensors. A tensor is a vector or matrix of n dimensions that represents all types of data. All values in a tensor hold identical data with a known shape. So all these things we have remembered and we already know this. The shape of the data is the dimensionality of the matrix or array. A tensor can be originated from the input data or the result of a computation. In TensorFlow, all the operations are conducted inside a graph. The graph is a set of computation that takes place successively. Each operation is called an op node and are connected to each other. And we have seen many other graph. We have seen the pictures of graphs, how they look and everything, right? The graph outlines the operations and connections between the nodes. However, it does not display the values. The edge of the nodes is the tensor. That is a way to populate the operation with data. In machine learning, models are fed with a list of objects called feature vectors. A feature vector can be of any data type. The feature vector will usually be the primary input to populate a tensor. These values will flow into an op node through the tensor, and the result of this operation will create a new tensor, which in turn will be used for the new operation. All these operations can be viewed in the graph. So let's see what are the agenda of this lecture. So you will understand what is a tensor, representation of a tensor, types of tensors, okay? And you'll see what is a shape. You will understand what are the operators, what are the inbuilt operators in TensorFlow. All those things we will understand in this lecture, okay? So let's begin. So first, let's see how to represent a tensor. So representation of a tensor. So in TensorFlow, a tensor is a collection of feature vectors, that is an array of n dimensions. For instance, you can have a single dimension array, a two-dimension array, or a multi-dimension array. If you have a 2 cross 3 matrix, if the array is a 2 cross 3 matrix, as I'm showing you in the diagram, it has 1, 2, 3, 4, 5, 6, which is a 2 by 3 matrix. So we write like 1, 2, 3 and 4, 5, 6. But the TensorFlow represents this matrix as a 2-dimension matrix, 1, 2, 3, 4, 5, 6. So you can see a 2-dimensional level. There are 2 pairs of square brackets, correct? So this is a representation for the 2-dimension matrix. Then what if we create a 3-dimensional matrix with values 1 to 8? Okay, so how to do this? Okay, so if we have this 3-dimensional array, if we create a 3-dimensional array matrix with values 1 to 8, it looks like this, right? It looks so 1, 2, 3, 4 at the front and 5, 6, 7, 8 at the back. So TensorFlow represents this matrix as 1, 2, 3, 4, 5, 6, 7, 8. So let's see the representation in TensorFlow. You can see here, it's a 3-dimensional array. So you can see the levels are 3. There are 3 levels. So 1, 2, 3, 4, 5, 6, 7, 8. And as the dimensions goes on increasing, the levels also go on increasing. Okay. So a tensor can be represented with a scalar or can have a shape of more than 3 dimensions. It is just more complicated to visualize the higher dimension level. So if you are not aware of 3-dimensional array, you can have a basic understanding of a 3-dimensional array, how to create it, what are the representation, what are the number of elements in a 3-dimension array. So all those things you can have a basics of them. Then the next thing is types of tensors. So what is the types of tensor? So in TensorFlow, all the computations pass through one or more tensors. A tensor is an object with 3 properties. So a unique label, a dimension, a data type. Okay, so these are the types of tensors. The computations pass through one or more tensors. A tensor is an object with these 3 properties, that is a unique label, that is a name given to the tensor, then the dimension, that is the shape of the tensor, and the data type, what is the data type of the tensor. Then each operation you will do with TensorFlow involves the manipulation of a tensor. There are 4 main tensors you can create. One is tf.variable, tf.constant, tf.placeholder, tf.sparse tensor. So out of these 4, we have already understood 3, right? So 3 types of tensors. We have understood how to create a variable, how to create a constant, how to create a placeholder, and we will see later how to create a sparse tensor. So let's have a basic program how to create a constant. So to create a constant, you can use the tf.constant function. So tf.constant, the syntax is it takes value So you can see the syntax, it accepts value, it accepts the data type, that is D type, then it accepts the name. Okay, so when you create a constant, you directly give a value. So value of n dimension to define the tensor. Then the optional D type defines the type of data, the data type. Then tf.string, tf.float32, tf.int16 are the available data types for strings, float, and integer variables respectively. Then name is the name of the tensor. This is optional. By default, it will take the name as constant _1:0. Okay. So for the first constant, it takes this name. For the second constant, it takes 1. For the third constant, it takes 2, like this. Now, so you can see the example. I'm not giving the rank and I'm not giving the name. I'm just writing r1 equals tf.constant. The constant value is 1 and the data type is tf.int16. So when we print this, you can see it's taking the constant as 0, the name as 0. Okay, the shape is nothing, and the data type is 16, int16. Okay, so as you can see, constant 0 is the name, shape is the shape, and there is nothing in it, and the data type is int16. Okay, next we will name a tensor in this next example. we will give a name as my underscore scalar. So my underscore scalar, you can guess that it's a scalar value. It's a single value. So R2 equals TF dot constant. The value is 1. The data type is int16. The name is my underscore scalar. You can give any name as you wish. Then when we print R2, you will see it's taking the name as my scalar, right? Then the shape is nothing and the D type is int16. So when you go on creating this iterator, this 0 becomes 1, this 1 becomes 2, like this. When you create more tensor, it starts from 0, then it goes on increasing one by one. Okay. You can define a tensor with decimal values or with a string by changing the type of data. So decimal. So if you want to create a decimal constant, you can write tf.constant 1.12345. The data type is float 32. Then when you print this, you will get the result as you can see in the output. So first let's complete this program. So for the decimal constant, we wrote this. For the string constant, you can write guru99, then tf.string. Okay. So now you can print r1 underscore string. So you can see the output. For the first tensor, it is showing constant 1.0 because we did not give any name. The shape is nothing and data type is float 32. And for the second tensor, the constant 2.0, again we did not give any name, so it's taking constant 2. The shape is nothing and data type is string. So next, a tensor of dimension 1 can be created. So let's see how to do that. So rank 1. So if you are creating a rank 1, you can go up. Yes, rank 1. So how to create a rank 1 TensorFlow? R1 vector. Okay, so you are not creating a scalar value now, you are creating a vector. So vector can be a row vector or a column vector, right? So R1 vector is equals tf.constant 135. Okay, then print R1 vector. Then R2 boolean is a tf.constant true, true, false. Okay, then the data type is tf.boolean, then print R2 boolean. So when we run this program, you will get the output. So tensor, the constant 3, constant 4. The shape is 3 and the data type is int16 and boolean. Okay, this is rank 1. So you can notice the shape is composed only of one column, right? Okay. Then the next is to create an array of 2 dimension. To create an array of 2 dimension, you need to close the brackets after each row. Okay. So to create an array of 2 dimensions, you need to close the brackets after each row. So let's see the example. We are creating the rank 2. So R2 matrix equals tf.constant 1, 2. So this is the first row. Then 3, 4. This is the second row. And the data type is tf.16. Then print R2 matrix. You can see it's constant 5. Then shape is 2 by 2. Data type is int16. So this matrix has 2 rows and 2 columns filled with values 1, 2, 3, 4. Next, we will see how to create the rank 3 matrix. A matrix with 3 dimensions is constructed by adding another level with the brackets. So how to add another level? You can see in the example, the rank 3 matrix equals TF dot constant. There are 3 levels of brackets. So 1, 2, 3, 4, 5, 6. So the data type is 16, int 16. Then when you print R3 matrix, you can see the output. So it's constant 6. The shape is 1, 3, 2. Okay, so 3 rows and 2 columns. Okay, so 3 rows and 2 columns. A set of 1 row and 1 column is its meaning of 1, 3, 2. So as I told you, if you don't know the how to represent the 3-dimension array, you just go to the basics of 3-dimension array. This is how we represent the shape, is 1, 3, 2, and the data type is 16, int 16. Then after this, we understood how to create a constant. We understood how to create a scalar, a vector, then a 2-dimension matrix and a 3-dimension matrix. Now let's see shape of tensor. So when you print the TensorFlow guesses, it already guesses the shape, right? So we saw in the previous outputs, it was also showing us the shape. But you can get the shape of the tensor by using the shape property. Okay, there is a shape property which we will use now. So next you will construct a matrix filled with a number from 10 to 15, and you check the shape of the matrix using the M shape. So M shape is a variable. M shape equals TF dot constant 10, 11, 12, 13, 14, 15. So this is a 2-dimension array, right? There are 2 levels of brackets, 10, 11, 12, 13, 14, 15. Then if you want to get the shape, you need to write the shape attribute mShape dot shape. So the output will be 3 cross 2 because it has 3 rows and 2 columns, right? Dimension 3, dimension 2. So this is how the TensorFlow shows the shape of a matrix. Then to create the matrix has 3 rows and 2 columns. So TensorFlow has useful commands to create a vector or a matrix filled with 1 or 0. For instance, if you want to create a 1-dimension tensor with a specific shape of 10 filled with zeros, you can run the code below. So we have this similar function in NumPy where we can create a matrix of all values 0 or all the values 1. Okay, so similarly, TensorFlow also provides the function zeros. So let's see how to do that. So print tf.zeros 10. So when you run this, the output, you can see tensor zeros. The shape is 10. It's a vector. Okay, it's basically a vector. So the shape is 10 comma and the data type is float 32. Then the property works for matrix as well. You can use this zeros or ones for the matrix as well to create a matrix also. So now let's see how to create a matrix of 10 by 10 with all ones filled with it. So output, so print tf.ones 10 comma 10. So the output tensor ones, okay, it is of ones function, shape equals 10 comma 10. Now the shape has become changed, right? Before it was 10 comma because it was a vector. Now it's a matrix. Shape equals 10 comma 10. Data type equals float 32. So this was about few things. We will continue this in the next lecture. All right. Thank you.